Hello everyone, my name is I am a radiologist at University Hospital Osijek in Croatia. In this video, I want to show you the whole process of making the personalized surgical guides for mandibular reconstruction using a free Fibula flap with our developed add-on for open source software Blender. So everything starts with loading icon data and segmentation of the bones, actually the mandible and fibula. I'm using a 3D slicer, and most of you will, well, not agree with me, but I like to perform semi-automatic segmentation, mostly manual, because I have more control and there is less post-processing in the software with cleaning of the model. So when you load the DICOM data, uh, over here you can write and change the name of the model because of the patient privacy. I'll just leave it segment 1. So uh, I'll go and change window. Okay, and now we have the bone. Uh, I'll do the threshold segmentation of the part of the segmentation. Let's see. Okay, I'm satisfied with that. I'll click apply. Uh, there's some parts. Let's check if there is connecting, if mandible is connecting with other bones. Okay, or delete. This this kind of segmentation is time consuming, but I have, as I said, better control. If you need help, there are some tutorials on the YouTube. There is a website called Embody 3D. Tutorials how to segment your desired DICOM data. Also, if you have troubles, there is a 3D Slicer forum, so you can ask everything on that forum. The guys over there are really eager to help, and there shouldn't be any problem if you have any questions. The part. Okay, now let's try to remove. Okay, okay. Let's keep the selected island so everything else is deleted. Okay, now if you're satisfied, I'm not. You can stop here and do the checkup of the model in some other tool, but personally I like to do everything here 3D slicer. This patient is from other hospital, so the scanning protocol is a little bit different than at my department and what we used to work, but we can do the segmentation, which we can use whichever parameters you want for segmentation, but personally I like the more thin slices. The resolution of the final model is better than if you have thick slices. Also, in the description I'll leave a link to our published article about the add-on, where you can find CT protocols for obtaining data of the mandible and lower legs. This is a case of huge ameloblastoma in a pretty young patient. You can turn the sphere brush so you'll have a little bit faster segmentation. Usually I like to take soft tissue reconstructions because the bones are smoother and there is not a lot of noise and artifacts as in sharp algorithms. Usually the segmentation is a little bit faster than this, but this is a hard case and I want to have a lot of details. Cortical bone over here is pretty thin because of the expansile growth of the ameloblastoma. Okay, let's go fix the other side. Okay, this is the foramen of the mandibular nerve, and for this case I don't need to show the nerve or the canal, so I'm just make the opening and close it later on because I don't need to. It's not as crucial value for this type of modeling and surgery. Okay, so this here is a mental foramen. You can leave it just as a landmark, anatomical landmark, but you can close it because sometimes it can leave well, defects, artifacts later on when you perform the surgical guide. So depending on you and what you want. Okay, I mostly leave it, but you can close it if you want. Okay, let me concentrate on the bone and teeth and close the gaps there, and later on I will concentrate on the cortical bone around the tumor itself.
I realized that I didn't record the rest of the segmentation, but I finished the segmentation of the tumor and the mandible. I used coronary and axial views for segmentation, and in 3D views I edited some artifacts and protruding bone and the gaps.
Okay, so I'm satisfied how this model looks, and now I will save it, but I will not show the process of seeing because of the patient ID and the GDPR. So next step is to import it into the other software for modeling. I will write the name of the patient here just for identification, and then clean up the inside. Oh, I'm not sure, can you see it like this, but if it is not connected to the outer shell of the mesh, it will be easily deleted. And maybe to further delete some of the sticking parts, just to ease the printing, and delete the unconnected parts also, like this, like floating in the air. And then I will slice it into the software for slicing and put it into the print. And before that, I will make the mirror symmetrical image of the lower jaw just to make a normal bone appearance for the bending of the plate for connecting the future graft to the native bone.
So these are two mandibles, the models after the 3D print. The first one is the uh, original native mandible with the tumor. It will be used to discuss with the surgeons where the osteotomy planes will be the front osteotomy and the more dorsal osteotomy. And the second one, the back one, is the mirrored this in the sagittal plane. It will be used for forming the plate for pre-bending of the connection plate.
Thank you for watching. And the same process I will perform for uh, right fibula and peroneal artery with its perforators for further modeling and generation of the cutting guide. Thank you for watching, guys. Bye bye.